All right, so the next step is to solve this using Euler's method, and we're using a step size of 0.5. Now, I thought about, showing you how I would really do it, which is program it up and everything else, but I think the more important thing here is that we learn how the method works, and so we're just going to go through this and do it by hand. So using Euler's method by hand, and I've rewritten the function here. And so we can go ahead and get started. Now let's remember what Euler's method is. Euler's method says yi plus 1 equals yi plus, let's see, f of xi yi times h. All right, so this is the equation. Excuse me, we're given one more piece of information. Y of 0 equals 1. All right, so this is it, and h equals 5. H equals 0.5, I mean. All right, so let's get started. So we say, we already know, so we're just going to write it out. Y0 equals 1. I don't know why I'm doing that. Y1 equals yi, let me just write it out, y0 plus f of y0, excuse me, again making a mistake, x0 y0 times h, which is equal to y0, we already said was 1 plus f of x0 y0 is going to be y0, y0, so sorry, let's just write this out a little bit more explicitly. So that's going to equal y0 plus, now f of y0, and we have x0, this is our t here, so that's t 0 cubed minus 1.5 y0. Okay, so now we're actually going to plug in values. So y0 again was 1, so that'll be 1 plus 1 times t0 cubed, so that's going to be 0, right? 0 cubed is 0, minus 1.5 times why not, and that was just 1 times 1. Okay, and so that is going to equal, all right, and I just remembered, I forgot all this has to be multiplied by 0.25, 0.25, and so then that is going to equal, so we've got 1, and so we've got 0 minus 1.5, so that's going to be minus 1.5, but that's going to be not times 0.5, and so half of 1.5 will be 0.75, so 1 minus 0.75 is going to be a positive 0.025. Okay, so now we say y2 equals, and so we can just read from here, y2 equals y1 plus y1 t1 cubed minus 1.5 y1. So that's going to equal y1, which was 0.25, 0.25 plus 0.25 times, oh, and again, again that's times h. Get a hard eraser, all right. Times times h equals, plus 0.25 times t1, and so t1 is going to be 0.5 cubed minus 1.5 times y1, which is going to be again 0.25 that is all times, and all that is times h, which is 0.5. Okay. All right, so the result of all that is, let's see, 0.781. No, 0.0781. All right, and so I think you get the idea. I'll start writing it out here. So then we're just going to have y3 equals y2 plus y2 t2 cubed minus 1.5 y2 times h, and that's going to equal, right, 0.0781 or plus, and this is all going to be times h, so that's going to be 0.0781 times t2 cubed, and t2 is going to be 1, right, because we're going by steps of 0.5. 1 cubed minus 1.5 times y2, which again, our y2 is right here, 0.0781, and all that's times 0.5. That's, well, we can slide over a little bit. All that's times 0.5, and if you work through that, you get, well, we can write it over here. You get 0.0586. Okay, so you see, and you just keep on going until you get to 2, and that is Euler's method.